Thermodynamics.com.
Okay, here we are going to start with the thermochemistry and we will try to complete with the all topics of the one thermochemistry. Actually, it is a one topic of the thermodynamics, but because of the importance, practical importance, we are going to study in detail one by one. Okay, so let's start one by one. So first, in the thermochemistry, the very first thing you should know is about the standard state. What you should know? You should know about the standard state. Okay. So these are very basics, but if you forget, if you don't understand it properly, it is going to be very difficult to solve the actual questions you are going to get. Okay. Many of the students neglect this topic, but once they are giving a typical question or twisted question, then they are not able to answer. Instead of getting plus 4 marks, they are getting minus marks. Okay, so to avoid the negativity, to avoid the negative marking, let us start and I will tell you the tricks where the question will be twisted and how you should manipulate that twisted question so that you can answer in the nice way. Okay, it is going to be entirely different from what you learn from the reading of the books or from any other lecture. Okay, so in this, with the experience after the going through the student experiences, I have collected some traps where misunderstanding is there among the student community that I am going to tell you. Okay, so first, enthalpy under standard condition. Actually, what is standard condition? What you study in states of matter is different, and here it is different. So, molar enthalpy of a substance under standard condition is called molar enthalpy. But standard state, what is mean by the standard state? Nobody knows and nobody interested to ask or nobody dare to ask because they may feel that it is very simple topic. If I ask, somebody may feel wrong. Okay, are bad, but once you get the bad marks, then it is going to be very poor. So let's start from the basic, but slowly I will improve the level to the advanced level. Okay, so which will help you to get the seat in AIMS or at IIT. Okay, so for a gas, if I say gas is at standard state, then it should be 1 bar partial pressure. Okay, it should have 1 bar partial pressure. For the gas, what is important? Pressure is important. What is important? Pressure is important. That pressure must be how much? 1 bar partial pressure. Okay, suppose if I take a liquid, then if I say it is at the standard state, okay, so it should be a pure liquid. It should be what? Pure liquid at 1 bar. At that should be the liquid state must be measured at 1 bar, but at any given temperature. But pure crystalline solid, okay, again it is 1 bar at any given temperature. Then substance or ion in the solution. This is very important. Mainly, I am marking it unit molarity. Molarity must be 1, and for the gases, 1 bar pressure is must. Okay. So this is not much important. This is not much important. These are very important. For the solution, standard state means 1 molar concentration. For gas, standard state means 1 bar pressure. For gas, standard state means 1 bar pressure. Okay, so this is about the standard state. Now once you have the basic concepts clear, then it will be easy for you to understand the other concepts. Okay, let us go to the next slide. So next slide is enthalpy of a substance. Enthalpy of a substance. Okay, as a every substance has got a fixed value. Okay, like internal energy we have studied in the basics of thermodynamics. Every substance will have fixed value of enthalpy at particular state only. This is a state function. Okay, so if you change the temperature, that enthalpy associated with the enthalpy available in the substance will change. If you change the pressure, enthalpy will change. That's why before giving enthalpy, we should make sure that state of the system is at given fixed finite value. Okay, so enthalpy of 1 mole of substance is called as molar enthalpy. Wherever is written as molar enthalpy of H2O, that means it is particular about 1 mole. Okay, so then it is M is written to show that it is M is written. Okay, so molar enthalpy of water vapor at 398 Kelvin 180 pressure is represented as delta HM. Okay, but if you are maintaining a standard temperature and standard pressure, we can represent it as a HM as well as naught. This naught shows that it is in the standard state. Already I have told you clearly about the standard state. Standard state, anywhere if you find that zero not in the right hand sub superscript, what it is called as right hand superscript, then it shows that it is at the standard state. Okay. So this is about the enthalpy of substance. Now we are going to start with the actual and very required topic. Okay, enthalpy of formation. What is the next one? Enthalpy of formation. Very, very important. So I am explaining and don't forget to uh, be with the attentiveness. Okay. So enthalpy of formation means, as the name itself suggests, that it should be formed. So let us take, we are talking about the enthalpy of formation of H2O. We are talking about what? Enthalpy of formation of H2O. Then amount of enthalpy change during 1 mole of molecule. During formation of 1 mole of molecule from the elements in elementary state. From where? Elements must be where? In the elementary state. Elementary state, what does it? I will explain with clear examples and some exceptional examples also I will tell you. So this will be a collection of the so many books. Okay. So H2 plus O2 gives H2O. Now you should always forget one thing. This should be only 1 mole. And what this reactant must be? Reactant must be in elementary state. Okay. So what is that elementary state? For the time being, leave it on to me. And it will be for balancing. You can keep it fraction, but never and ever change. Never and ever change this thing. Okay. So this is very, very important over here. This is very, very important thing. Okay. So, okay, 1H2O is very important, and these thing must be where? In elementary form. In elementary state. Reactant must be in elementary state. Product should be only one. Okay. So this should be what? Single. It should not mingle. Okay. It should be what? Single. Okay. So no mingling is allowed. Understood? Only one product must be there, and number of reactant can be any number. But how they should be? They must be in elementary state. So during that reaction, whatever the enthalpy change is taking place, that is called as a enthalpy of formation. And that enthalpy of formation is specially denoted with a lovely symbol of delta FH. How it is denoted with delta FH. What does it F stands for? Formation. What does this F stands for? Very good. It stands for the formation. Here F stands for, F stands for formation. Okay. F stands for formation. So this is enthalpy of formation. Okay. Now standard enthalpy of formation means temperature must be, if I write circle here, temperature must be how much? 25 degrees Celsius. Already standard other than the temperature I have already mentioned. Okay, or I will mention once again 1 bar pressure. Okay, 1 bar pressure. This enthalpy must be measured at 125 degrees Celsius, at 25 degrees Celsius and 1 bar pressure. This is about the enthalpy of formation definition and important traps. This is a big trap. Okay, don't be in this trap. So sometimes they may give 2 moles. So you have to divide the entire equation by 2, then you will get the enthalpy of formation. Is that clear to all of you? So let's see the next one. Next slide goes over here. Okay, as I told you, this will be a collection of so many important information. Standard state. If somebody says standard state, I will give you some lovely examples. Okay, what is that lovely example here? Graphite. Okay, and where one more thing is there, wrong, white phosphorus. Okay, so these are the two lovely examples you should remember. What is that? White and graphite. These are the very important examples. And one more thing I am going to write over here, that is the VIJ CHEM speciality. Okay, so what is that? That here I am writing it here, delta F H naught, delta F H naught of H plus is 0. Okay, delta F H naught of H plus is 0. So this is very important. Okay, so what you will remember, what I have told you separately, I think it is now clear. So standard states of some element. So carbon got so many variations. Okay, so people are much worried about the it's one of its state diamond. Okay, and people are more crazy about the one more of its state. What is that? Fullerene. What is that? Fullerene. Okay, but the authorities have given enthalpy of formation of graphite, enthalpy of formation of graphite as how much? 0. Enthalpy of formation of graphite as 0. Okay, so graphite as a 0, is it understood? This is 0, this is 0. Okay, so why? Because when the authorities asked why you are worried about the graphite, okay, depending on the abundance. Okay, this is the most abundant, abundant, abundant. Okay, mostly available in the universe is graphite. That's why they took this value as a 0. Sulfur got many allotropic forms, monoclinic sulfur, rhombic sulfur, but which sulfur enthalpy of formation is 0? Rhombic sulfur enthalpy of formation is 0. Bromine is the only non-metal which is liquid at the room temperature. So before assigning enthalpy of formation of bromine 0, you should check. What you should do? You should check whether it is in the whether it is in the liquid state or not. After checking yourself, then you will answer. Okay, when it is in the liquid state, then only you will take it as a 0. Now same way with the with the iodine. Okay, for the iodine it should be how much? It should be solid state. Hydrogen, it should be in gaseous state. Chlorine, it should be in gaseous state. Nitrogen, it should be in gaseous state. Oxygen in gaseous state. Okay, see, phosphorus, white phosphorus, these two you will never and ever forget. Okay, so red, actually phosphorus have red phosphorus also more stable, but due to the more abundant nature, white phosphorus is taken as a enthalpy of white phosphorus taken as what? 0. Okay, so here I have written and standard enthalpy of for chlorine is 0, hydrogen is 0, oxygen is 0, bromine is 0, I2 solid is 0. Is that understood? So this is going to be very important slide in your career to make it very bright. Okay, So let's go for the next one. Okay, now we are going to start with one of the most and very most important definition, enthalpy of formation. Enthalpy of formation, already I have explained you, but for the board exams, this wording is must. Okay, the compound is in the change in the standard enthalpy when 1 mole of the compound, 1 mole of the compound is formed from the starting from requisite amounts of element in their stable state of aggregation. Stable state of aggregation means elementary state. See, this HBr at the stable state is our element standard state is gas. Okay, so it is prepared from the hydrogen, which is elementary from bromine, also elementary form. And I have cross checked. What about you? Have you cross checked this one? You should cross check about the state of the bromine. Okay, so hydrogen must be in gaseous state. So once after cross checking only, these three cross checking. What is that cross checking? First of all, product should be only one. Okay, product should be only 1 mole and only one type. Okay, there should not be nobody associated with the product. Okay, and all reactant must be in elementary state. What do you mean by elementary state, and what are the exceptions? Reason for the exception also I have given. Okay, so this is the standard enthalpy of formation. I think now it is clear to all of you. Let's move on to the next slide. Enthalpy of combustion. Okay, during the ranking after the formation, next ranking is given to enthalpy of combustion. Okay, enthalpy of combustion is denoted by delta CH. How it is denoted? Delta CH. If I am able to maintain standard state, what standard state, then only I will put this sign. Okay, what is this sign? Standard state. Okay, so if I am able to maintain, then only I will write as a standard. Okay, if I am not able to maintain 25 degrees Celsius, then I should not a standard state. Okay, so this is not oxygen, this is circle over that. Okay, so it is the enthalpy change when 1 mole of the compound, how many mole? 1 mole of the compound combines with requisite amount. There is no problem of the oxygen, you can use as required. Okay, to give product in their stable forms. Okay, so here there are only two reactant permitted. How many type of reactants are permitted? Only two types of reactant are permitted. One must be what? Oxygen. Okay, one must be oxygen. Another is the compound about which we are talking. Suppose here we are talking about the enthalpy of combustion of methane. Okay, so then methane will be the other reactant. See, very dangerous. This should be how much? 1 mole. Okay, so before answering, will you check is it 1 mole or 1 mole? Okay, so without checking this 1 mole, you will never and ever answer. Okay, so how many reactant must be there? There must be only two reactants. What are those two reactants? The compound which is undergoing combustion, and the other the compound which is making the combustion possible. Who is that person? That person is none other than the oxygen. Okay, so after making sure all these, if it is maintained, then that value is called as a enthalpy of combustion. What is that called as? Enthalpy of combustion. Okay, how to denote this? C stands for combustion. Okay, this is the enthalpy of combustion. We can say simply amount of heat. Enthalpy is nothing but heat only. Okay, total heat content of the system. Total heat content of the system is named as enthalpy. Okay, so that enthalpy, total amount of heat liberated when 1 mole of the given compound completely undergoes combustion. Okay, now elementary state means, see, I am giving you elementary state. Suppose if I write oxygen, this is only made up of only one type of element, that is oxygen. Therefore, it is elementary state. But once I write CO2, now this is compound state. What is this? This is called as a compound state. Okay, this is called as a compound state. Anything which contain two or more than two type of atoms in it is called as a compound state. Anything which contains only one type of atoms, then it is called as a elementary state. Okay, so this is about the enthalpy of combustion. Now, enthalpy of combustion is for 1 mole. Okay, one more related term is there, that is called as a calorific value. What it is called as? Calorific value. So, enthalpy of combustion divided by molar mass, divided by molar mass will give you the enthalpy of calorific value. Okay, because calorific value, enthalpy of combustion is for 1 mole and calorific value is for 1 gram. Calorific value is for how many grams? 1 gram. Then it is called as a, for getting 1 gram you have to divide the enthalpy of combustion. Very important formula. Okay, so very important thing, so don't forget to write this formula. Okay, what is that formula here? Listen very carefully, and there may be a question, related to this. Okay, calorific value, CV means calorific value, is equal to enthalpy of combustion divided by its molecular mass. Suppose here 890 is the enthalpy of combustion. 890 into 10 to the power of 3 joules. Okay, divided by methane. Methane molecular mass is how much? 12 plus 4, that is 16. Now this total, it is going to be calorific value. Okay, so very important formula. I think everybody will remember this and solve the all questions related to it. Okay. So here enthalpy of hydration. Next one is enthalpy of hydration. So enthalpy of hydration are further divided. For the advanced level I am telling you, they are further divided into two parts. For anhydrous or partially hydrated salt. Okay. Anhydrous partially hydrated salt means anhydrous or partially, like CuSO4. What is this? CuSO4. You don't find any water here. Okay, so if I write 5H2O, okay, so let me take another color. Now if I include all of these, then it is called as a hydrated. What it is called as? Hydrated. If I take only red color one, okay, then it is called as a anhydrous. What it is called as? It is called as anhydrous. Okay, anhydrous copper sulfate, and this is hydrated copper sulfate. Okay, so what we will do, we will keep on adding the water to it. Okay, now the amount of heat released. See, it was anhydrous, and after adding 5 moles of complete water molecule, then it liberated minus 78 kilojoules. So this is called as a enthalpy of hydration of copper sulfate. Okay, again I am repeating, listen carefully. Enthalpy of hydration of anhydrous salt is amount of heat liberated, during its conversion, from the anhydrous state. See, Initially what we have anhydrous. From anhydrous state to hydrated copper sulfate. Then it is called as a enthalpy of hydration. Okay. Amount of heat released during conversion of 1 mole of anhydrous salt into the hydrated salt is called as a enthalpy of hydration. But this I am talking about the anhydrous or partially hydrated salts only. This is not final. Okay. So let us see the what are the other parts. Second part. Okay. The second part is enthalpy of hydration of gaseous ions. Okay. So this you will find in the Born-Haber cycle, which you must have studied in the chemical bonding. Okay. What is that? Born-Haber cycle. Okay. So in the Born-Haber cycle, you will study about the enthalpy of hydration of gaseous ions. Okay. So after dissociating into gaseous ions, once they got dissolved into water, they will form enthalpy of solution. Okay. So see, this is called as enthalpy of solution. Okay. So enthalpy of hydration, is it understood? For gaseous ions, it must be converted from gaseous state to aqueous state. Okay. So just now I told you enthalpy of formation of H plus aqueous can be taken 0, can be taken as 0. Okay, next one is enthalpy of neutralization. What is the next one? Enthalpy of neutralization. Okay. So neutralization is simply acid plus base gives salt, gives salt plus water. Okay, gives what? Salt plus water. Acid plus base gives salt plus water. This is called as a neutralization. So whatever the amount of heat liberated, during this reaction is called as enthalpy of neutralization. What it is called as? Enthalpy of neutralization. Okay, when an acid react with base to form salt and water. So there are lot of definition in lot of books. So amount of heat released when 1 gram equivalent. This is very important word. Okay, 1 gram equivalent of an acid neutralized by 1 gram equivalent of base. Okay. Otherwise, amount of heat released in the formation of 1 mole of water. Because see here, salt can change, base can change, acid can change, but water will always be unique. So that's why during formation of 1 mole of water, okay, when acid is neutralized by the base. Next, enthalpy of neutralization can also be defined as when 1 mole of H plus from the acid combined with 1 mole of OH minus from the base to form water. Okay, so this is called as enthalpy of neutralization. Now for strong acids, for strong acid and for strong base, enthalpy of neutralization is 13.7 minus 13.7 kilocalorie or minus 57.1. In some books it is given as minus 57.27 also. Okay. So anything you can make it as acceptable. So minus 13.7 in terms of the calorie, minus 57.1 in terms of the joules, kilojoules per mole. Okay. So this is about the enthalpy of neutralization. And some more important points we are going to study. Okay, after noting down this neutralization, enthalpy of neutralization, what you have to remember, this 13.7. Okay, sometimes they may ask why it is fixed. That time what you should say, it is just a reaction between. It is the amount of enthalpy change released when 1 mole of water is formed. Okay, and in the definition also it is given 1 mole of water, and here 1 gram equivalent of acid neutralized by 1 gram equivalent of base. Okay, so like that you should be able to identify the reason behind that constant value. Okay, now let's see the next one. Okay, next slide is about the enthalpy of ionization. Okay, so there is a minute difference between ionization and neutralization. Okay, see here, whenever a weak acid, that value is applicable only when strong acid and strong base combines. Okay, so but when a weak acid combine with strong base, or strong base, weak base will combines with strong acid. Okay, weak base with strong acid or weak acid with strong base, then will be less than the 57.1, will be always less than the 57.1. See, NaOH is a strong base, but when it is treated with the HCN, it is liberating only 12 kilojoules. Okay, but at the same time, if we use the acetic acid with the same base, it is able to liberate minus 57.1. Okay, so that difference is called as enthalpy of ionization. Okay, so here it is 12 kilojoules, but how much it is supposed to be? 57.1. The difference between these two, minus 57 minus of minus 12. Okay, then you will get the x value. Okay, by just afterwards we will study about the SS law of constant heat of summation. In the last, I am going to teach you. So don't leave the lecture in between. Continue up to the last, because S law of constant heat of summation is very much important. Okay. So that can be calculated, and this can also be calculated. Likewise, we can find out enthalpy of ionization by the amount of decrease from the highest possible value. Okay, so let's see the next topic. Okay, next topic is about the enthalpy of transition. Next topic is about what? Enthalpy of transition. When 1 mole of one allotropic form changes to another. See, carbon, graphite is also allotropic form, diamond also allotropic form. Okay. So whatever the, actually this is not possible in a laboratory to convert graphite into diamond. Okay. But that value, whatever the enthalpy we require or release, we can calculate by using the Hess law. Okay. So what is enthalpy of transition? Amount of heat change, heat required are released during conversion of 1 mole of one allotropic form into the another allotropic form, like diamond, graphite are allotropic forms, monoclinic and rhombic sulfur are allotropic forms, red phosphorus, white phosphorus are allotropic forms. So what during that transition, whatever the heat change released, heat change required is called as a enthalpy of transition. Okay, so I think it is clear to all of you now. Okay, now let's see the next slide. Enthalpy of reaction from the bond enthalpies. Okay, so our aim is to calculate what? Delta RH, but what will be given? Bond energies will be given. Okay, so simple summation of bond enthalpy, amount of energy required to break reactants. This is the only place you will get the reactant first, then product afterwards. So bond enthalpy of all reactant minus bond enthalpy of product. Then this value will be the enthalpy of reaction. Okay. So enthalpy of reaction is simply sum of the bond enthalpies of reactant minus sum of the bond enthalpies of product. Okay. So I think it is clear to all of you now. Now next, let us go to the next slide. Okay. Next slide is resonance energy. Very, very, very important. So many times in advance we got question from this topic. Okay. So difference between energy of resonance hybrid and resonance structure. Okay. So actually there will be many resonance structure will be there. Many resonance structure will be there. Okay. Many resonance structure will be there. But when you combine all of them together, then you will get resonance hybrid. What you will get? Resonance hybrid. Okay. So that hybrid resonance will have the lowest energy. That will have the lowest energy and they will have the higher energy. So the gap between the difference between the resonance structure and resonance hybrid is called as a resonance energy. Okay. Hybrid will have always lower energy because it is most stable. So how you will find out enthalpy of resonance is equal to experimental and calculated. With the bond energy or combustion formation, we can calculate without doing the experiment, but then we will calculate after the experiment. Okay. The difference between them is going to be resonance energy. Okay. Very important topic. Don't forget to remember this topic. Okay. So very, very, very important topic. Is it understood? Now let's go to the next slide. Bond enthalpies, lot of confusion, lot of misconcept in the students about the bond enthalpy. Okay. So actually speaking, bond energy is not fixed. Suppose people feel that this bond energy will be same. See, this is the practical experimental proof. So when I am breaking the first hydrogen from this, then amount of heat liberated will be, heat required was 501.87, but second hydrogen liberated are broken by using the 423.38 Kelvin. So what we will do, we cannot take this one, we cannot take this one. In that condition, we take the average of this. Then we will get bond enthalpy. What we will get? We will get the bond enthalpy. Is it clear? Okay, here bond enthalpy is 501 in the first step and 423 in the second step. This will be the actual bond enthalpy. Okay, so let's go to the next slide. Now, phase changes, enthalpy during the phase changes. Okay, so actually a substance can exist in solid, a substance can exist in liquid, a substance can exist in the gas. So whatever the heat required are released, amount of heat required to melt, melt means solid to liquid, at constant pressure and 1 atm pressure. Okay, constant temperature and 1 atm pressure, that is called as a enthalpy of fusion. So this will be the enthalpy of fusion. Okay, now liquid to gas, that will be the enthalpy of vaporization. This will also be amount of heat required to vaporize 1 mole of substance at constant temperature and 1 atm pressure. Okay. Now certain substances can directly convert from solid state to gaseous state. Then it is called as a enthalpy of sublimation. Okay. So this is all about the enthalpy changes during the phase transitions. During what? Phase transitions. Okay. Now let's see the next topic. Enthalpy of atomization. So name itself says atomization. That means it should be converted into atoms. So here hydrogen is a molecule. It is broken down into atoms. Methane is a molecule. It is broken down into atoms. Now don't get confused this with the bond energy. Actually here 4 into bond enthalpy of carbon dash hydrogen is equal to enthalpy of atomization of methane, because during conversion of methane molecule into respective atoms we have to break 4 carbon hydrogen bonds. Okay, so that is about the enthalpy of atomization. Okay, now let's see the next slide. Then Hess's law of constant heat of summation. Okay, this is very important and don't forget to by heart this. Okay, so these two definitions are very important. Okay, so let us see the states. It states that change in enthalpy of any chemical reaction is constant whether reaction occurs in one single step or in several steps. Suppose we wanted to convert carbon into carbon dioxide. At a stretch we can do it. At a stretch we can do it. We can do it for converting carbon into the carbon dioxide, or we can convert into carbon monoxide then to the carbon dioxide. Okay. So this is suppose delta H. This is delta H1. This is delta H2. Okay. So delta H1, delta H2, delta H3. So according to this, what they say, whether it is a reaction carried out in one single step, then delta H1 will be equal to delta H2. Okay. So this is about the law of constant heat of summation. Enthalpy change on reaction depends on initial and final state only, but it is not depends or independent on the path followed to completion. Okay. So this is very important for the numericals. Now let's see the next. These are the main important topics we have studied. Now other than this, what I will tell you, what you will remember. Okay, what you will remember is, first of all, neutralization you will remember, enthalpy of neutralization. Okay, enthalpy of combustion you will remember. Okay, and enthalpy of formation you will remember. Okay, enthalpy of formation. These are the very three important topics. Other than that, resonance, enthalpy of resonance, and Hess's law. Okay, so these are the few important topics I suggest you to study once again, so that you will not lose any marks. Okay, thank you for watching and stay with us, and get good score in all type of examination. And don't forget to see the description box. In the description box you will get all detailed lecture one by one. Some numerical sessions also there, some theory sessions also there. Whichever topic you have, you will see in the description box. Okay, description box means you will have a triangle like this. Okay, you will have a triangle like this. When you press, you will find here link. Okay, so link, then there will be a playlist. Once you open that playlist, all videos will be displayed, whichever topic. Suppose you are having more doubt on the Hess law, you can go through that Hess law video lecture. That in the thumbnail itself you will have the detailed about the what is explained in that video lecture. Okay, don't forget to share this video to your friends who are classmates personally, so that they can also be benefited. I hope you all will do, and don't forget to like this video. Okay, see you. Bye bye.